Okay, so here's an example of a trick that only exists in base 10. This is just for kicks, basically. So here's the number 2,718. If I want to know if this number is divisible by 3, I add up all the digits. 18. Right? Add digits is a dumb step, but it happens to work for this. Right? So you add the digits, you get 18 base 10. Add the digits again. You get 9 base 10, which you recognize as a multiple of 3, and so you say, aha, is divisible by 3. Okay, so one thing you might be interested in is this trick doesn't work in other bases, right? This trick is a base 10 trick. So there are other base 10 tricks. Base 10 has a lot of these tricks, which is one reason that base 10 is stuck around. We maybe, by the time we realized kind of like, oh, I have 10 fingers, but math is better in base 12, right? Like maybe it is. If it was, we probably would have moved there after we realized that. It turns out it's not, except in some special cases. So there's some kind of fun tricks that you can do in other bases. So if you have a trick that's very important for you, you might convert all your numbers to that base, or to a base where that trick exists. Does that make sense? That's not super common. Like, most of the time you just cram calculations in a computer anyways, right? So I think computers have been the death of moving to bases other than 2 or 16.
This might be a dumb question, but what defines a base? Like, we have base 10, that goes 1 through 10, and then it kind of starts over. But like, and that, I grew up with that, I know how that works. Like base 16, like does it go up to 16 and then start over? Or
close. Base 10 doesn't go to 10 and start over. Base 10 goes from 0 to 9.
Right.
And then starts over. Okay?
Okay.
So base 16 is going to go from 0 to 15 and then start over.
But then
and base 2 is going to go.
When it starts over, what does that look like versus?
Yeah, let me show you.